Hi, guys. Welcome to today's episode of Algebra After Dark. We are going to go through the homework from, see real quick here, from section 8.9. I'm going to do all the even numbered problems for you. I know their answers aren't in the back. I started just to write down what the answers were and kind of found that that probably is not going to cut it for something like this. So let's go ahead and jump in with problem number 14, which is our first even number one, which says that 1/3 to the power of x is equal to 6. When I have a variable in the exponent, my go-to move is to take a log of both sides, and mathematicians love the natural log. So I will take the natural log of both sides. And I will tell you that this step that I wrote right here, you don't actually have to write. Okay, I can kind of vaguely cross that out. Not that it's wrong by any stretch of the imagination, but if you knew to do this step, presumably you knew why. And the reason that why we do this is that if you have a natural log of something to an exponent, the exponent can become a coefficient. And so most people won't write that second step and will just go straight on to this. And then in calculator ready format, we get the natural log of 6 over the natural log of 1/3. It would be the same answer as if I put in the log base 74 of 6 over the log base 74 of 1/3, but my calculator does not do log base 74s. I'm going to switch it up a little bit, what calculators I use. I'm going to start here with kind of the standard one, which I think most of us have, and just type this in. Natural log button is right there. Of 6 divided by, and there's that exact right spot to get it at where you can see what's going on the screen. Natural log of 1 divided by 3. Hit the enter button, we get a negative number. It is that. As they said in the instructions, the nearest thousands place, which is that one right there. So negative 1.631 is how that would round. Approximately negative 1.6, I already forgot, 31. Okay. 1/3 to the -1 would be 3. 1/3 to the -2 would be 9. So definitely somewhere in between -1 and -2. That seems to make sense. The next problem I find to be of the even more difficult variety. Number 20, we have 3 to the power of x minus 4 equals 7 to the power of 2x plus 5. So same strategy here. And again, if you want to skip this step, that is perfectly acceptable. Equals the natural log of 7 to the 2x plus 5. You can just go right on to this step. X minus 4 times the natural log of 3 equals 2x plus 5 times the natural log of 7. Now, if we remember that natural log of 3 and natural log of 7 are just numbers, it might be kind of ugly numbers, but they are just numbers, then this isn't so bad. Do feel free to lament with me that it will look ugly, but it's really not that hard to do. I'm going to distribute, and you get x times the natural log of 3 minus 4 times the natural log of 3 equals 2x times the natural log of 7 plus 5 ln of 7. I'm going to move everything with an x to one side. So I got my x ln of 3 and a minus 2x ln of 7, and everything without an x to the other side equals 4 ln 3 plus 5 ln 7. Okay. For simplicity, I'm going to do this in 2 steps, but you really don't have to. I'm going to factor out that x. With an ln of 3 minus 2 ln of 7 equals 4 ln of 3 plus 5 ln of 7. And to get a final calculator ready answer, get that x equals 4 ln of 3 plus 5 ln of 7 over ln of 3 minus 2 ln of 7. And that is in calculator ready format. Again, I'm going to use the kind of standard calculator here and type that in, find that sweet spot where I can see the screen. Move it over so I can see what I'm doing. Ooh, I've got a cat walked in here with me. That's going to end poorly if it wants to get out. All right, and we've got a 4 ln of 3 plus 5 ln of 7. Oops, a little problem with my parentheses there. Second insert, boom. And that looks good. That is the numerator. I'm going to take that numerator and I'm going to divide it by, in parentheses, the natural log of 3 minus 2 times the, again with the parentheses, 3 minus 2 times the natural log of 7. Enter. And I get a negative 5-ish. Right. Again, we'll check to make sure that makes sense. So we got 3 to the negative 9, so a pretty small number there, equals 7 to the negative 5-ish. Okay, seems about legit. And so again, there's my answer. The nearest thousandths, it would be negative 5.057. Okay, moving right along. The next one we had to do was 26. This one doesn't look so bad. In fact, I don't think I see a little treat here for us. X equals negative 9. And there's the problem. And right off the bat, I'm going to say that there's no solution. If we wanted to, we could write this as x ln of 1/9 equals the natural log of negative 9, but negative 9 is outside the domain of natural log. You may not take the natural log of a negative number. Basically, we're asking e to what power would equal negative 9, and there's no power you can raise a positive number to and make it negative. So that can be nice and quick. Let's see how many of these I'm doing. There's 26 that we just looked at. We have 32 and 38 left from this group. Okay. So slightly different looking setup here for number 32. Number 32 looks like 3 times 1.4 to the x minus 4 equals 60. All right, I'm just going to do a little order of operations stuff and get rid of some things. 3 times 1.4 to the x equals 64. 1.4 to the x equals 64 thirds. A little bit on the ugly side there, 21 1/3 if you prefer, but it doesn't really matter. I am going to skip the step, which we're allowed to skip, and write this as x times the natural log of 1.4 equals the natural log of 64 thirds. And say that x equals the natural log of 64 thirds over the natural log of 1.4, and plug that into a calculator. Let's mix things up a little bit and go to one of these bad boys. So clear there, and we've got the natural log of 64 divided by 3. Still have to remember to close those parentheses, divided by the natural log of 1.4. We hit enter, we get about 9, and to the nearest 1,000ths, it would be 9.095. Right. Again, seeing if that makes some degree of sense to our original problem. Something less than 2, we'd have to take it all the way to about the 9th power, multiply it by 3 and subtract 4 to get 60. I can just see whether or not that seems to make sense here. I'm going to say 1.4 to the power of that answer. And I get 21-ish. 21 times 3 is about 63-ish. Obviously, the 1/3 is going to make it 64. Minus 4 is 0. All seems legit to me. Okay. The last one from this group. Ooh, this is kind of fun. The last one from this group is number 38. And it says 3e to the 2x plus 2e to the x equals 1. I'm going to rewrite it slightly to be 3e to the 2x plus 2e to the x minus 1 equals 0. All right. If I write off to the side that u equals e to the x, then I can rewrite this as 3u squared plus 2u minus 1 equals 0. So a very useful technique of substitution there. Remember, 3e to the 2x is 3e to the x squared. And so this all seems to work out. Let's see whether or not this thing is factorable. I think it looks like it to me. 3u and a u will multiply together to get my 3u squared. A 1 and a 1 will get me that 1 over here. If I do this as a plus and this as a minus, the negative times a positive is that negative 1. 3u times 1 is 3u, minus a u is 2u, and that seems to work. So according to this, 3u minus 1 equals 0. That's my 0 product property. Or u equals positive 1/3. Of course, u could equal negative 1 according to what we have here, but can e to the x ever equal negative 1? No. So I'm going to substitute again back into e to the x. E to the x equals 1/3. And so x equals the natural log of 1/3, using natural log and e as inverses of one another. And just as an estimate, since I kind of think of e as being around 3, so 1/3 is like 1 over e. So I'm guessing I should get a negative 1-ish. So I am taking the natural log, of 1 divided by 3, and I get a negative 1-ish. So as a number rounded to the thousands would be negative 1.099. Sounds good to me. Okay, and that is it from that section. However, there are more. Let's see. Do page, okay, 41 through 50 all. Okay, so I guess the next one is just 42. Solve each equation, give solutions in exact form, meaning no more calculators over here. 42, 3 times the natural log of x equals 9. Therefore, the natural log of x equals 3. And x should equal e to the 3rd. Again, there's kind of a missing step in there. I'm going to say that e to the natural log of x equals e to the 3rd, but e to the natural log of anything is just that anything. We also had to do number 44 here. So let's get that one going. 44, natural log of 2x equals 5. Natural log of 2x equals 5. Again, I could take e to both sides, e to the natural log of 2x. Well, that's just 2x equals e to the 5. And so x should equal e to the 5 over 2. Right, and I had to do problem 46. Number 46 reads the log of 3 minus x, and this is a common log. The log of 3 minus x, lost my place here, there it is, equals 0.75. So I'm going to rewrite that as 10 to the 0.75 equals 3 minus x. I'll add x to both sides, subtract, and I get that x equals 3 minus 10 to the 0.75. 48, the log base 5 this time of 8 minus 3x is equal to 3. 5 to the third, therefore equals, weird angle on this. Sorry about that. Equals 8 minus 3x. I can rewrite that as 125. I forgot the 2 in the middle there. Equals 8 minus 3x. Adding 3x to both sides, subtracting 125. We get positive 3x equals 8 minus 125, which should be negative 117. Sounds right to me. And x equals negative, and 117 is divisible by 3. We should go in 3 times, and that would be the 90. So I get 27, so 9. That's right. I guess I should have just called that negative 120 minus 3, and so dividing, I would have gotten 40 minus 1 in the same place. Okay, last one from these is number 50. And number 50 says the log base 7 of x cubed plus 65 is equal to 0. So 7 to the 0th equals x cubed plus 65. Well, that's just 1. If I subtract 65 from both sides, I get negative 64 equals x cubed. I will take the cube root of both sides, and I'll get that x is equal to negative 4. And that's perfectly fine. Oops, sorry, I was off screen for most of it there. That is perfectly fine that x is a negative number. I am not taking the log base 7 of x. I'm taking the log base 7 of x cubed plus 65. And that is a positive number. Okay, I think I had one more problem I needed to do. Yes, on page 480, number 16. 480, number 16. Decay of plutonium. Repeat exercise 15 for 500 grams of plutonium-241, which decays according to the function this A of T, my amount at any time, equals my A naught is how that's pronounced for initial amount, E to the negative 0.053 T. Okay, and we're repeating exercise 15, which said a sample of 500 grams, so there's no original amount. Find the amount of radioactive lead remaining after 4 years. Okay, so we started with 500, 500, e to the negative 0.053 times 4 will be my first amount. And then the next one, I'm just going to plug in an 8, then a 20, and I will find the half-life as well. That's a slightly different thing. Let's switch back to old blue here, Faithful Blue, and type this in. On 500, on that sweet spot where we can see the calculator real nice. 500 and second natural log will give me e to the negative 0.053 times 4. I'm going to hit enter, and most of it's remaining there. We get approximately 4.0, excuse me, no zero there, 404.48. I believe this was in grams. Yes. And if they don't ask, I always find rounding to the hundredths to be just about appropriate. As opposed to plugging anything back in, I'm just going to go over here and switch this number to an 8, hit enter, and I get that 327.21 grams. Sorry, that's off the sweet spot somehow. Per sec. Yeah, that's pretty decent. And again, when they wanted 20 years, I'm just going to go right back up here, go over here and change that 8 to a 20, hit enter, and now I'm down to 173.23 grams. Okay, next they asked me to find the half-life. And I'm going to do it the way most people do, where they say, oh, well, if you started with 500, and after one half-life, you're down to 250. Equals 500 e to the negative 0.053 t. However, when I do it that way, my first step is to divide both sides by 500, and I get this 1/2 here. And my point is that regardless whether I started with 1,000 and said, oh, I get down to 500, I started with 1 and say I get down to 1/2, start with 3 and say I get down to 1.5, when I divide, I'm always going to end up with this 1/2 here. So really, this is where I'm going to start. 1/2 of whatever my initial amount was. I can put in a little A0 here and put in a little A0 there, and the A0s go away. That initial amount goes away. All right, I'm solving for something which is in the exponent, so I'm going to take the natural log of both sides. All right, the natural log of 1/2 equals, I want to take the natural log of e to something, it just goes away. Negative 0.053 t, and so my answer really is the natural log of 1/2 divided by negative 0.053. Let's see what that works out to be. And that's Swedish spot. Natural log of 0.5 divided by, in parentheses, we'll do a negative 0.053. And we get a syntax error. Ooh, what did I do wrong? I put a minus, it likes a negative. And I get that 13.078. That, so approximately 13.08 years, which makes some good sense. If we go back up here, remember, after 4 years, we didn't lose half of it. After 8 years, we didn't lose half of it. After 20 years, we lost more than half of it. So somewhere between 8 and 20 for sure, that seems legit to me. All right, thank you for playing. I will see you guys next time.